welcome to another session in our series on programming for Android with App Inventor. My name is Stephen Hughes. This video serves as an overview for our unit on basic data manipulation. In this unit, we're going to focus on extending our apps to do useful operations for our users. We're going to start by looking at the input processing output model. This is a nice framework that helps us to focus our attention during the design process. It's pretty basic. Let's take a look. So the idea is pretty simple, right? You have a user who's providing some input to a device, which then does some processing, and then displays that the results of that processing to the user as output. Again, it's a pretty simple concept, a pretty straightforward, pretty intuitive idea. But the reason I think it's valuable is it provides a nice framework to help us focus our attention during the design process. It helps us ask the right questions. We might need to ask the questions: what information do we need to get from our user? What kind of manipulation do I need to do with the data that I have? And how am I going to communicate the results back to my user when I'm all done? We can also extend this IPO model when we think about interactive applications. Again, the user may provide some input to the application, which does the processing and provides output to the user, which then becomes input to the user's processor. The user in their brain then does some processing of what they're seeing. They're interpreting the results and figuring out what actions to take next. And when we have this kind of interactive feedback loop represented in this picture, we get a more interactive, dynamic sort of app developed. But again, it's based on that core idea of input, processing, output. The only question is, who's the processor? And that's another important question we can ask when developing our apps, is what processing is going to take place in the app itself versus what processing is the user responsible for. Once we have that division of labor kind of marked out for ourselves, we can move on here and think about how we're going to handle the processing, how we're going to do the programming for the actual app side of things. One of the things that's pretty important to understand is the idea of a state of the program. Now, we've already experienced this a little bit. I haven't used that term, I don't think. But the idea of a state of a program is it's the collection of all of the objects that make up that program. If you think about what we've been discussing so far, we've put components onto our viewer, onto our screens, and then we described those objects in terms of the various properties. Well, all of those properties as they're set for all of the components make up the state of the program. You can ask things like, what's the current drawing color? Or is this button enabled or not? Or am I listening for events on this button? What events am I listening for? Right? That all encompasses the idea of the state of the program. And that is where we get a lot of our input and a lot of our output from, is manipulating that state of the program. Along the way in the processing, sometimes we have to represent data that's external or isn't necessarily explicitly represented on the screen. And that's where we get into the question of dealing with literals and variable data. Now again, we've already experienced literal data in our apps that we've developed so far. Remember when we pushed the button in our very first app, what did it do? The app literally displayed the words, "Hello, App Inventor," every single time. Literally, that's all that was there. Right? We can also think of literal data as being parts of formulas. For example, if I want to convert inches to centimeters, I know that there's some conversion factor. I might not remember what it is, or I might remember that there's 2.54 centimeters in an inch. Right? That 2.54 is always there. It's literally, that's the conversion factor that I want to work with. However, in that same app, the number of inches that I want to do the conversion on is variable. It depends on the user input. I may want to store that and represent that internal to my program so that I can then manipulate that value. And that brings us to steps 4 and 5 here that we want to discuss. There's different kinds of processing that we can do. A lot of the processing we think about computers doing is arithmetic. We think of the computer as being a good tool for helping us do mathematical operations. It's very good at doing all the basic operations on your calculator, doing addition, subtraction, multiplication, division, right? We can use those arithmetic operations to do certain kinds of calculations for us. Like I just said a few minutes ago, we can do metric conversion. We can calculate the areas of various shapes. We can calculate speed, or maybe the slope or intersection points. We can do all sorts of arithmetic processing. We can do those basic arithmetic operators. We also have the ability to do some of the more advanced arithmetic operations, like taking advanced functions like trig functions, cosine, sine, tangent, raising to powers, all sorts of arithmetic processing that we're used to thinking about in terms of math. But we also know that computers are good at doing text processing as well. Example of the kind of text processing we can do is searching a collection of text to find a certain keyword and replacing that keyword wherever we see it with another word. We can think about taking a text document and parsing it out, dividing it up into semantic components, right? A lot of data that we deal with is comma-separated values. If you think about how you take your Excel sheets and you make them comma-separated values, and when we divide those categories into columns, that's kind of text processing that we'll deal with. And I'm going to show you how to do that in App Inventor. Let's go ahead and get started.